Hey class, so in this lesson we're going to be going over the basic Revit elements, walls, floors, curtain panels, doors, etc. And we're going to be basically trying to recreate this house. So real simple geometries, got giant, way unrealistic cantilevers and some glass, some different material properties, railing, um, and we're just gonna have some fun with it. It's not gonna be exact. We're just gonna be integrating a bunch of different model elements into it to start to create the geometry and the form. And then the assignment will be to kind of add your own flavor and submit that as part of your assignment. So to access it, I've uploaded this image onto Canvas. So it's under here, under the rendering sketch. I'll probably rename that actually to contemporary house sketch. All right, and you guys can download that and reference that from there. So like I went over in the initial tutorial, we're going to be using the Revit template that I've uploaded as our base for all of the projects moving forward. So we'll go to New and then set up your project browser from there. So I'm going to actually show you guys how to set that as your default so you don't have to go find it every single time. So let's just OK that for right now. So that'll open up the project template. And then to set a default template so you don't have to go searching for it every time, go down to Options and then File Locations. And then, oh, here we go. So project templates, go Add Value, click, or go and find, and then click the practice template, hit Open, and then you can move this up or down depending on where you want it. And then now, once you've done that, now if you go to File, New Project, it will show up here. So you don't have to go browsing for it. All right? All right, so we need to set up the levels. So in the template, it's already set up a level 1, a level 2, and a roof, which is realistically what we need. I need to find that image again, which I apologize. There we go. For some reason, my cloud does not like my mouse moving from window to window. All right, so we have two levels. They seem to be relatively the same size. And then, so we'll make them all the same. So right now it's 12 and 24. That's realistic, but for the sake of the tutorial, let's change it. So actually, let's go ahead and delete the roof. I'll show you guys how to create a new level. Real simple. There's a couple ways to do it. One is to just take an existing level and copy it up or over or wherever you specifically want it. That creates a new level. The other way, if I go and delete this, is to go up to our Architecture tab and then go over to the Datum group, hit Level, and then you can click and drag and create a new level that way. All right. And then to edit the level, whether it be its name or its elevation, all you got to do is click on the level itself and then click into the name. So we'll call this roof level for right now. And then let's change the elevation to 30. All right, and then let's change level 2. Remember, click on the level, then click the elevation, change that to 15. There's another way to do that as well. All you gotta do is click and then go over to the properties window that we reviewed last time. Elevation, same thing. You can change it to 14. You can change the name here. And you can do all of that and it will update here. So there's a couple ways to do it. There's a couple ways to manipulate information. That's pretty typical across Revit. and it's really, it just becomes whatever you prefer. So now that we have our 2 or 3 levels set up, let us go in and start sketching. So let's go over to the level 1 floor plan under the project browser. And let's start sketching stuff out. So I don't know why I keep actually closing the sketch. All right, so the first floor plan looks relatively simple, just a rectilinear form. It doesn't get funky until level 2. So let's do that. Oh, come on. This is getting real old. I'm gonna have to get my IT guys to do something about this. All right. Oh my goodness. Come on. It wants to come in. There we go. All right. All right. So under the architecture tab, first we'll create a floor. So under the architecture tab, there's a floor button. Click that. And then it's going to bring you to a sketching window that brings up this draw dialog box, and it has all of your different drawing tools in it. So you can do lines, you can do rectangles, circles, click and drag. Pretty self-explanatory. And the nice thing about Revit is it also, if you hover over the specific element that you want to click on, it'll actually give you a diagram and sometimes actually have a video showing you how to use each specific element. So if we hover over line, it gives you a definition of it, and then it actually shows you what you need to do. I think like if you hover over trim and or this is a line, excuse me, it'll actually pop up with a video of how to use it. All right, so if you ever get confused, or if you're ever wondering, like if I go too fast and you're wondering how I actually use that specific tool that is selected, that's a shortcut that you can use to show. So first floor is just a simple rectilinear geometry. So we'll just create a rectangle. And then there's a couple ways that you can change the dimension of this box. One is to click on one of the sides. It will typically populate a dimension underneath it, which you can click and then edit. So if we make that 100 feet. And then same thing here, it'll populate with the window, do 30. Probably a little big, but oh well. The other way you can do that is to use a dimensional tool. So the most popular and the most easily transferable dimension is the align dimension, but you have a couple that you can choose from. So if we click the align dimension and click the two lines that we want to dimension, it'll populate a dimension tag off of that. And then if we click one of the elements, it'll come up as blue and kind of highlighted. That means that you can edit the dimension and type in whatever you want, and it will grow. You can also click, excuse me, the hiccups. You can click and drag. It's just a less controllable way of editing the dimensions. So we have a 30 by 100 box. So let's make it 90 feet. And let's do it using a dimension. Press checkbox if you want to finish and create, X if you want to cancel and discard what you've done. Oh, and before we hit the checkbox, over on the right side of the properties, when you're in this edit tool, it will populate the different type of floor. So I'll go through that right now. So in walls, with floors, with roofs, that kind of stuff, you can select what type you want by clicking the tab here under properties and selecting one of the types of Revit element that you have selected. So in this case we have we have floors selected. So we had 4-inch concrete slab. Let's change it to just a generic 12-inch. We can also change what level we want it associated with, the height from that level, etc. So let's just keep it level 1 for right now, and the height is 0. And let's check or click the checkbox. And my mouse has disappeared again. This is great. Oh, that's frustrating. Okay, so now we have our floor, and we can, if you want to move it around in your window, for right now, since we have nothing else created, you can just click and drag, and you can drag that floor around. I'm going to center it between all of these elevation tags. These are elevation tags that are associated with each of the elevations that are in our project browser. We'll get into how to access those later. So right now we have a floor. If we go into our default 3D view, which is up at the top, we can see that here. Pretty simple. And I'll show you exactly. So if you click the floor level, you can begin to manipulate its specific properties by changing them here. So it was associated with level 1, now it's associated with level 2. If I change this height offset from level, it's going to give it a height above the floor line. So if I say like 4 feet, then it raises 4 feet above level 2, which it's associated to. I'm just going to undo that. And yeah, so let's create the levels for the level 2. So what we can do pretty quickly is just copy, Control C, sorry if you hear that siren, Control C, and then go to level 2, modify, and paste. So modify tab, paste from clipboard. And then if you do this drop down, you can do a couple different pastes. You can say align to selected levels. You can say align to current views, align to same place. Let's do align to current view. So I clicked from level 1 to level 2. So now if I say paste to current view, it's going to paste that same floor, but to level 2 instead of level 1. You can do the same thing if you're in a 3D view. If you copy and paste to selected levels, if you click that, then it brings up this window where you can actually select the levels you want that element pasted to. So if I said level 2, or if I said level 2 and roof, pressed OK, then it would copy that element up to both level 2 and the roof. Somewhat self-explanatory. All right, so all I want it on right now is level 2, and I'm going to adjust that to best fit our house. So our house has a cantilever, looks like, sticking out. Let's see, probably the same dimension as our depth. So let's do 30 feet. Let's just do, let's do 30 feet. Just arbitrarily offset. And now we have to use a couple of our modification tools up at the top. So the first one we're going to use is the split element tool. So it cuts any element in half. So I want to cut this line into 2. So if I go to the kind of the middle between our two cantilever walls and click, what that's going to do is that's going to split this line into 2 specific elements. And then I'm going to go up and select the trim and extend to corner tool. What that does, trim and extend, pretty similar to CAD as well as Rhino. Just click the 2 lines that you want to trim and extend to, and they will extend or trim that line to make a nice clean corner. Now, be careful on which side of the line that you choose. right? So if I choose this side of this line and to trim and extend there, then it's going to create that corner on this side instead of where I want it to be, which is on this side. All right. Hopefully everyone's following along. All right, and then what I'm going to do now, go to roof, and I am going to basically going to trace the outline of that floor, but I'm going to create it using a roof tool. And the first thing I got to do, the interesting thing about Revit is it allows you to control the depth of the view that you're in. So let's say I'm on level 3 and I actually want to see the site and the ground plane. I can adjust the view parameters so that I can extend the view all the way down to the ground so I can see the detail. And in contrast to that, if I'm on level 2 and I don't want to see that, I can control that as well. And to do that, what you want to do is go over to your properties of your floor plan, your specific view. Go down to view range under the extents tab and hit edit. That will populate this window. It'll give you a top range, bottom range, and the view depth. And so right now it's associated with the level that we're on, which is the roof. However, we want to be able to see this level 2 so we can see the floor slab that we want to trace around. So what we want to do is change the bottom of the level to level 2, change the bottom of the view depth to level 2, press OK. Now we can see the level 2 floor slab. Then what we can do, go into the architecture tab, and instead of hitting the floor, we go into the roof and do roof by footprint. You have a couple different options, but today we'll just be focusing on roof by footprint. And you can trace it a couple different ways. Obviously the simplest one is just to use the line tool and go around and snap to the different sides. But there's another tool that you can use. It's this green line with a mouse over it. It's called Pick Lines. What you can do is use that to select different edges or faces of geometry that are already existing in the model, and it will create a line to mimic that specific geometry, that specific edge. And you can actually, if we delete all that, you can actually use that Pick Lines, and if you tab using the tab tool, and click a couple times, you can cycle through the different elements that are underneath your mouse. And typically, if there is a piece of geometry that has a completed boundary within that view, you can use that and it will highlight that entire perimeter so that you don't have to go through and select every single individual face to create that entire perimeter. Excuse me. All right, so now that we've done that, hit checkbox. Now we've created a roof. It defaults to this kind of insulation, but let's just change that to a generic 12-inch. All right, so if we go to our default 3D view, now we've created these 3 geometries. And our house sketch, the roof seems to be a little bit thicker. And the floor slabs seem to be a little bit thicker. And I think that's just an aesthetics thing. Typically that'll be a fascia with a soffit. But for right now, we're going to cheat and just make the floor slab and the roof slabs a little bit thicker by just changing the structure of them. So to do that, what we want to do is click on one of the floors. And right now it's a generic 12. We're going to make that a little bit thicker. So to do that, we go to Edit Type. So this is where we edit the actual types of floors. So we'll edit type. It'll bring up this window with the type properties where we can either duplicate this and create a new one, or we can just rename it. I'm just going to rename it for right now, which brings open this window, and I'm just going to call it generic call it 24 inch. Press OK, then go to, oh, sorry, I went a little fast. So that changes the name, but to change the actual structure and makeup of the floor itself, we want to go to Edit Structure. That brings up this window, and this is a pretty common window when we're playing with either wall, floor, roof structures, any kind of element that has multiple layers or can have multiple layers in it. It's going to bring up this window, and you can actually put in multiple layers of materials in this. So let's say we had a floor that was built up of tongue and groove wood flooring over soundproofing over a concrete and metal deck. Then we could add all of those layers in, and so when we cut through that floor, we could actually see all the different layers of that floor. For right now, for simplicity's sake, we'll just do 2 layers. So we'll just do the 1 layer, but I'll show you how to insert a new layer, which is the Insert tab right here. And you can, by selecting it, you can move it up or down. And then to change the actual material of it, you can go into the category. So that's the material category. If you click on this, it's very indiscreet, but there's 3 dots right next to it. You have to click that to go into the material manager page. So if you click that 3 dots, and sometimes it takes a while, it'll bring up this page. This is the material browser. This has all of the different materials that you'll find within your project under one roof, and you can create, manipulate, change, delete all the different materials. So for right now, and it has the names backwards, of course. There we go. Let's go to our default. You can either scroll or you can actually type in default, and it will bring up all the materials that have default in the name or somewhere in its description. So what we're going to do is select the default, right click, duplicate, and hit, let's just make a generic white material, and then go over to the color. So that creates a new material. And of course, we've lost it since we searched for default. So let's go back to white. All right, white. Click that. Then once you have that selected, it'll bring up all of its different properties and appearances on the right side. Graphics is, how do I explain this best? That's what you'll see in certain aspects. It's kind of like in Rhino, where you have shaded or wireframe or ghosted. These are where you edit those kind of graphics. So it's typically solid colors or different surface patterns if I want a concrete texture on it, or if I want dash lines or backslash, that kind of stuff. I can associate those patterns here. And then the appearance tab is your rendered appearance, right? So that's where you get into the real fine detail of what a material looks like when you put it through a rendering piece of rendering software. So like if you wanted to throw it up to the cloud and run it through Autodesk rendering system, if you put it through Enscape, it's going to look like what you have set in the appearance tab. So for right now, we'll just focus on graphics. Since it is the white material, we'll just change it to white just by clicking the color, and then obviously changing the color to white. And then you can have a surface pattern. If you click on it, click on none, and it'll populate this tab. This is a drafting and a model pattern. Basically the difference between the two, a drafting pattern is going to hold its specific size depending on the scale of the drawing. So let's say I want this aluminum hatch to be the same size, whether I'm in a 1/4 inch scale half-inch scale, 3/32, it's going to maintain its true dimension no matter what the scale is. A model pattern is a real-life size of the lines, right? So that's why in drafting view, it's kind of like different material patterns, whereas in model, it's actual sizes, so 12-inch tile, 4-inch parallel. Those are going to maintain their true sizes no matter what the scale of the drawing. So I'm going to go down under drafting, sorry, and just, oh, maybe it's up here. Yeah, so solid fill. In 2020, Revit 2020, it defaults up to the top. I believe in 2018 and maybe 2019, you have to scroll down to S to find it. But solid fill, press OK, and then we can change the color under the color tab, change it to white. You can either move that up here or just select one of these guys. Press OK. Press OK. Now we have white. And let's just create 2 white layers. And since it is our generic 24-inch, let's change the thickness of the second to 1 foot, therefore creating a 2-foot thick slab. One other thing. So the core boundary, you can actually associate different types to each layer. So if there's a membrane layer, if the structure, this is the structural deck, if it's a thermal layer, etc., you can associate that there. That doesn't have too much in regard to what we're doing now, but it sometimes plays a factor in how your floor organizes itself. So once we have that done, hit OK. Then we don't have to edit anything else here, so let's hit OK. And now those have changed, not only this one, but also the other material that was our original generic 12-inch, because we just renamed that type, and so it changed all the other types found in the file. So now that we've changed the floor slab, what we want to do is change the roof slab to be the same thickness. And realistically, just for simplicity's sake, let's make it the same material. So let's select the roof slab and go over to the roof properties and hit edit type. And then go in, let's rename it. Actually, let's duplicate it. Show you what that does. It's pretty close to the same, except instead of renaming that specific type, we're actually creating a copy of it. So we keep the old type and we're creating a new one. So let's just create generic 24-inch. And then same as the floor slab, go into the edit structure. And then instead of going into the materials properties like we did before, all you have to do now, if you know the name of the material that you want to associate with it, all you have to do is go in, type in the name of the material, and it will associate that material to that layer. And then instead of creating two layers of the same thing, let's just go in, click on the thickness, and type in 24 inches or 2 feet. That's the nice thing about Revit too. It's a little bit better than Rhino even. Is you can type in 1 foot, 5 1/2 inches, just like that, and it will recognize exactly what it needs to be. You can also type in, let's say, 2.75 feet, and it will automatically do the decimal to inch conversion, which is kind of nice. But for right now, we're just going to do 2 feet. Press OK. Press OK again. And now it creates a 2-foot slab. All right, so now we have 3 slabs, all the same size, 2 foot in depth. And what we want to do now is go in and start to create some walls. So let's go back to our level 1. Go to the wall tab underneath architecture. And then same thing as in floor, kind of. Sorry, there's a couple different tools in here, but it gives you some drawing tools to use. Now, with walls, since it's actually going to create an actual thickness of the wall associated with it, you have to tell where you want it to be associating with the line that you're drawing. So for example, right now, the location line is on the wall center line. What that means is if we zoom in and we have generic 8-inch wall selected, if you click and then draw the line, if you see that blue dashed line, it's creating the wall completely centered on where we're drawing the line, right? So if I change it here, it's moving the geometry of the wall with my mouse aligned to its center. So if you click, then it creates the wall, and now you can move the wall geometry by using these blue marks, and they're associated with the center line. Now, if you have the wall selected and you go over to the properties and you change the location line from wall center line to, let's say, finish face exterior, it actually changes the tabs that you can create, or the tabs that you can use to modify the wall geometry from the center to the exterior finish face, and then you can use it to move. Okay, same thing if we're creating a new wall, right? So click wall again. This time, instead of the wall center line, you move it to finish face interior, right? When we go and click for the wall, it associates the geometry of the wall with the inside face of the wall itself. So it draws the line to the inside face of the wall. When we click, it changes where you can actually manipulate tab. And if we go in and let's say we change it to the exterior finish face, it shifts to the front. Okay, and this is, it's a little bit hard to distinguish the exterior of the face from the interior face using a generic 8-inch wall. But if we change that to, let's say, is there a, here we go. So if we go to one of the, like, brick on a metal stud, for instance, of course it doesn't show us. Okay, there we go. So what I just did, so this is a brick on metal stud, and it's just still showing me a generic mass for the wall. The reason that is because the level of detail of this specific view is on coarse, and you can change that down here on the bottom left, which I should have covered in the original video. But this is a couple more tools that you can use to manipulate the geometry. So this first one here, detail level, you can change it from coarse to medium to fine, and those all have varying levels of detail associated with them. If you hit fine, then you can actually see the layers of the wall, right? And many of you may know that's kind of the symbol, one of the symbols for masonry is that dashed line, and then you have the stud layer, chip layer, and the 2-inch barrier, 2-inch airspace barrier. Another way to make it a little bit easier to read is up here at the top, thin lines. So if you click this button, it will actually take all of the line work and the line weights and create one standard thin line weight, so you can easily recognize different layers or detail associated with geometry. Anyway, getting a little bit off track here. So the reason I brought that up is because right now it's on the finish face exterior, which is always or primarily going to be your brick face. If we switch it to interior, it's going to be the opposite side. All right, so getting back to actually creating walls. And what am I doing on time? 35 minutes, okay. So let's just create a generic 12-inch wall. And if we looked at our sketch, the wall of the first floor is inset from the slab up top. So let's go a little bit inside. Let's just draw just randomly. Doesn't have to be perfect. And just like when we're drawing our floor slabs, if you want to change the dimension of our walls, all you gotta do is select the geometry that you want to shift, and it should come up with a dimension. You can change it here. You can also do a dimension of the wall itself. So right now I'm snapping to the center line of the wall. If you tab over, you can tab to the actual outside or inside edge of the wall if you want to measure from there. All right, and let's kind of center this. So real quick, if you click and drag from left to right, kind of like AutoCAD, it only selects what's in the dialog box that you clicked and dragged. But if you go from right to left, it selects everything that dialog box touches. So I just want those inside boxes. So you can click and drag different geometry. You can also use the arrow keys to go up, down, left, right, whatever you need. So this is relatively centered. So we have that. Now let's go to our level 2. Oh, before I do that, if we go to our 3D view, right now our walls are coming up, it looks like, just below the center of our, or the top of our second floor. So what we want to do is, if you select a wall, under instance parameters of under the properties bar, you can change the height, and you can do a couple different things with that. So right now our base constraint, or the bottom of the wall, is located at level 1. Right now our top constraint is unconnected, right? So that just says that our wall is, the bottom is located at level 1 and it's 14 feet tall. Doesn't matter what level is above it, below it, it's 14 feet tall. We can change this top constraint to level 2. That will actually put it up and align the top of that wall with level 2 and make it 15 feet tall. If, because it's associated now, if we went in and changed the height of level 2, so let's say we select level 2, hit move and drag it down, that wall moves with it, just like the level is, because the level is associated with level 2 and the top of this wall is associated with level 2. The 3 other walls did not change because they're unconnected. They're just plain 14 feet tall no matter what. If we changed the top constraint of this wall to level 2, it's going to shift down. If we change the top constraint of this wall to the roof, it's going to move up to the roof. Hopefully that makes sense. So I'm going to associate all of these walls to level 2, and what I'm going to do, and if you tab over when you have a wall selected, you can typically do all of the walls that are tied together with that one wall that you initially selected. You can change the top offset, and you can either go positive or negative. So the bottom of the floor slab is 24 inches below the finished floor line, or where our level is. So we want to go negative 2 feet below that. And now the top of the walls are sitting at the bottom of this floor slab. Okay, let's put our level back to where we originally wanted it, which is at 15 feet. So you can do that a couple ways. Oh, you know what? I apologize. to anyone that's using Revit 2018 or potentially 19 who don't have these levels in shoot. Okay. Another way to see the levels, since some of you might not actually see these levels in 3 dimensions, is if you go back to your level 1, you can go to a elevation, right? So to access the elevations, you can either double click on the arrow of the tab, or you can double click the actual name of the elevation view in here. Then you can see the elevations of the levels. I'm sorry, elevations, which are the views of the facade, and then the actual elevation changes of the levels. I apologize if I'm saying the same thing, or if I'm being confusing by using them interchangeably. But if you want to change the elevation of the level, you can go in, or the height of the level, excuse me, I'll use that moving forward. The height of the level, you can go in and change it here. Now, because all of our geometry is associated with that level, it will change automatically with it. Okay. Personally, I like modeling and creating my forms, going back and forth in the 3D view with the 2D views, because it validates a lot of the decisions that I'm making, and I know that the geometry is performing exactly how I want it to. If I was just building this in plan view, it might not show up exactly how I want it in elevation and so forth. So I'll use a combination of floor plans, elevations, and 3D views, sections, etc. to go back and forth while working in 3D to make sure that all of the geometry is working how I want it. So now we've created the walls on the first floor. Let's create the walls on the second floor. If we go to level 2. And if we look at our sketch, there's a solid wall here, and then it kind of jets in and creates a balcony. So we'll do that here. So let's go to the wall tab again. Generic 8-inch. Let's change the finish face to exterior, and then we can make sure that when we select the edge of our floor, it snaps to that edge. Now, our wall has oriented itself on the wrong side. We want the wall to be on the inside face of the floor slab instead of the outside face. All you got to do, hit the space bar, and it will flip this orientation of the wall. So space bar flips that, and that does for a lot of different things: doors, windows, etc. So comes in about, I don't know, a third of the way down, then it jets in. And for some reason, it's not. Oh boy. Okay, this is weird. So I was drawing and it wasn't creating, or it wasn't visualizing the walls. And there could be a couple reasons for that. One is that walls aren't in the view template. Another could be our view range, which we went over earlier. So if you go down to the view range in properties, go to edit. For some reason, our cut plane is at 20 feet. We can change that to 4 feet, which is pretty typical in terms of architectural floor plan. That's pretty consistent across the profession, is 4 feet above finished floor line. Press OK, and there's our walls. And then we can continue drawing. Alright, so that goes a little bit down and then pops out, down, comes out on the cantilever a little bit, then jets in, goes over, and then can't see it, so we'll just mirror this. So we can mirror these walls. So if you select the wall and hold Control. It'll bring up the little plus sign next to your mouse. That means that you can select more than one element at a time. And if we go up to the top, hit mirror, we can draw the mirror axis. And then we can go to the center of our floor, which propagates as a triangle. Click, drag up, which creates our mirror axis. And it mirrors the geometry over. And then we can continue drawing. And we'll just create a simple box. Okay, so now, just like in our the level 1, it defaults to 14 feet. Now we could have changed that. If we go into our initial wall selection, we can actually change that to roof and draw, and it will change the level properties to roof. But since we didn't do that, we can once again just select, hover over the wall that we want to change, and if we want to select all of the walls within the boundary, we can hit tab. It will select the chain of walls, and then we can just select up to level roof, and it will change the level roof. Now, another thing to be considerate of is if we go into an elevation, the dimension between the top of this floor slab and the top of this floor slab and the top of the roof is actually different. And that is because a floor orients itself, orients the top face of the floor to the level that it's associated with, whereas the roof associates the bottom of its geometry with the level of which it's associated. So what we can do, because in our sketch they look pretty equal, is we can actually just go in and either move the slab down so that they're equal across the entirety, or we can, if we undo it, we can select the roof, go to base offset from level, and just hit -2 feet, and now they're all the same. And once again, if we go to our 3D view, we can highlight all of the walls. Once again, tab once you hover over a wall to select all of the walls in the chain. Go to top offset, type in -2. Now they're all associated with the bottom level of that roof slab. All right, so one thing I forgot, so looking at the sketch, is actually this back wall is actually back aligned with the back of this wall on level 2. So there's 2 ways to do it. You could just manually move it. And I'm recording, okay. Or I could align it. So if you go to the Modify tab and then go to your Modify group, Modify, and then Align, which is the first tab there. If you click that, you first click the face of the geometry that you want to align the second piece of geometry to. So you can click this wall up top, and then click the wall that you want to move back to align with the wall above. And now if we pan around, you can see it's actually aligned back to that. Excuse me. And let's see, if we go to level 1, so what we got to do now is actually change the solid walls that we have modeled to the glass glazing that's in the sketch. And freaking mouse. And I just noticed that this wall actually has a little jog in it on the first floor. So if we bring that down, we go back to our wall, draw in the little jog, and then use the trim and extend tool to trim this corner. All right, so we've right now just created basic walls, and basic walls are, all these different types, and we can edit the structure of them, edit the materials of them if we so choose. But there's another type of wall, and that is a curtain wall family. In the curtain wall family, it's under the walls. If you do go to the drop down of the type and you go all the way down, it's distinguished here. And we can do one of two things. We could actually go to the exterior glazing. Let's do storefront, since that's technically what this glazing would be. So we click storefront, and once again we make sure that it's associated with the levels that we want. So we want it at level 1 up to level 2, and we actually want it to be -2 feet below level 2, so it aligns with the bottom of the floor slab. And then there's two things that we could do. We could actually embed the glazing inside the wall by clicking and pasting. What that does is any kind of glazing system that you draw inside a basic wall or more solid wall geometry, it will actually embed itself like it would a window. And since this is floor to ceiling, it looks like it just has replaced the wall. But if we went in and changed the top of the top of the wall of the storefront to, let's say, -5, so it actually embeds itself so that the original wall is right there, and the curtain wall system, the storefront, is actually inside that wall. So if we dragged it down, you can see there's the original wall, there's our new wall. And that helps us in a couple different ways. It's more relevant in other building types. If you have punch window system or a storefront system that's surrounded by or framed by solid wall, you can use it there. So that's one way of doing it. I just wanted to show you. The other way is to actually just select the wall and go to the drop down and change it to the storefront. Since in this specific instance on this project, the full height of the wall is the glass system, so realistically we can just change it there. And then there's this 2 arrows. If you hover over it, that allows you to change the orientation of the wall, just like if you hit space, it does the same thing. So right now in this storefront system, the glass, which is this piece right here, we want it to be more front facing, so we want to orient it to the other side. And then if we delete the wall that we had originally embedded in the generic 8-inch wall, and we go and do the same thing that we did before, where we go down and change it to storefront. We can also go down to most recently used types, change it to the storefront that we used there. We can just say OK here. Same thing, change the wall orientation. And then we can trim and extend, which the shortcut for it is TR. So if you hit TR, then it pops up with the trim and extend tool, which you can then use to align the 2 walls together. And this one technically would be more like this. So that's what I'm going to do. And then if we go to the front, change that to glazing. In curtain wall, so if we go in a curtain wall family, if you select it, go over to edit type. So instead of the structure that you find in a basic wall family, now you get a lot more parameters that are associated with curtain walls, because they control the curtain panel type, which is the glass type or the solid panel if you have that in there, the spacing of the grid, so the vertical and the horizontal mullions that you have within the wall, you can actually control the spacing of. And then you can also change the type of mullions, what type or what mullions are continuous, so which ones run continuous along the face and which ones get broken, etc. So for right now, let's just do glazed system panel, yes. Vertical grid, continuous, yes. Maximum spacing, let's do 5 feet. The horizontal grid though, there is no horizontal grid in the sketch. So let's just do none. And 2.5 by 5 inch mullions, that's fine. So let's press OK. And it's coming up with this window because the original 8-foot horizontal grid that we had in there, we just removed, so it wants to know if you want to delete it. We'll say yes. All right. And then the other thing that's in this this drawing right now is what looks like wood paneling. And how are we doing on time? Let's get the rest of this detailed, and then we'll do. Actually, no, we'll do the wood paneling now. So it looks like it's actually separate from the curtain wall, and it's a typical basic wall. So let's drag up our curtain wall. Let's go into the wall. Let's go back to our generic 8-inch wall, but instead of using it, let's go back to the type parameters. Let's duplicate this wall, generic 8-inch wood. All right, and then let's go into the structure and go into the materials. And well, we already have a wood material here, which is an ugly shade of orange. Let's change that to an brown. It's also pretty ugly. There we go. A little grayer. Whatever. And since we have what looks to be horizontal paneling, let's change the surface pattern to a model pattern type. And let's do 4-inch parallel lines. And what we can do right now, they're black because the color of the pattern is black. We can go in and just change that to a gray to make it a little more subtle. Press OK, press OK, press OK. And then go into our instance parameters. Make sure, yep, level 2, -2. Center line of the wall, that's fine. Trim and extend that to that. And then if we go to a default 3D view, look at that. Oh, and for some reason our one curtain wall, and yours may be correct, but mine is going all the way up to level 2. So let's put that back down to -2. Well, that's pretty good. Now the curtain wall spacing in the sketch is a little bit different, but for right now we'll just leave it at 5 feet. And then up top we have somewhat of a similar condition. So let's do this. Let's change these two walls to the generic 8-inch wood that we just created. And then let's go up to level 2. Let's go to wall. Let's go down to our storefront that we created. Make sure that the parameters are correct. Yep, up to roof, -2. And then let's embed it within the wood wall that we just created. All right. See, this is the one thing that I don't love about embedding curtain walls within walls is sometimes you get these weird leftovers that aren't right. So I'm just going to cheat a little bit, drag this one down so it gets rid of that, and drag this one down as drag this one down as well. And if we go to a 3D view, like that, pretty close. Another thing, so if we wanted to control these grids, the vertical mullions, what we can do is go into the edit type for the storefront family and change this from maximum spacing to none. And let's just delete the grid line, right? So now we have a blank glass wall that we can add vertical mullions to. If we go up to the architecture tab under build and hit curtain grid, this allows us to actually go in and place the grid line where we want it. So maybe it's a 10-foot pane of glass and then another 10-foot pane of glass, which would be extremely expensive in real life, but hey, this is a sketch, and then 5 foot, etc., etc. Up top, something small, next to something big, whatever. You can go in and set custom placements for your vertical panels. I apologize for my hiccups. Oh, okay. And then we can do the same thing for our cantilever over here. Change these two walls to the wood panel. Let's change this one just to the storefront. Unjoin, which is fine. Let's go to level 2. And we can bring these back. So one of the reasons why I'm showing you guys the different ways, the embedding versus just drawing it over each other or whatnot, is to just show you guys that there's a lot of different ways to build a Revit model, and you have to be the one to determine which is the best method. Sometimes it's if you want to be able to manipulate the model easy, maybe it's just an efficiency sake, you can do one way quicker than the other. It's really up to you on a case-by-case basis. Let's just add a curtain grid back in there on either side. Oops. And just break that one up. All right. And then the one last thing that we'll review today, since we're a little over the hour mark, is railings. So railings are pretty straightforward. They're under the architecture tab under circulation. If you click it and you go to the drop down, there's a bunch of different ones. Glass panel is what we'll use today, and it really just wants a path for it to draw on. So from the sketch, it looks like it's inset a little bit from the front face of the wall and the floor slab. So we'll draw it a little bit inside, and all it wants is that path. Doesn't need to be closed. It can be open. The only thing it will not like is if you draw two different paths, right? So if you have two different separated paths, it's going to give you this error down here. What you got to do if you want those two railings is you got to create two separate instances of that railing. So if you hit check, if we go to tab, then we can see it's created a railing. We can do that for the cantilever as well. Here, actually, let's show you the offset tool. So, like walls, like when we were creating our floor boundary, you can use any of these drawing tools up at the top. And what we can do is use the pick lines to select the outside boundary of the floor slab. Click and drag these up so that they're in line with the wall. And then we can use the offset tool under modify to offset the lines in from the face of the slab, the 8 inches or so that we have before. So up at the top, underneath the main window, or main ribbon, excuse me, is a couple different parameters that you can manipulate for offset and for a couple different tools. If you leave this copy on, it'll actually create a copy of the line instead of offsetting it in individually. And then obviously you can change the distance that you want it to offset. So we want to offset all the lines inside. We don't want it to copy 8 inches. And so you can do it one at a time, or like we've been doing, you can tab and select the entire chain, offset them inside the 8 inches, hit check mark, and now we got 2 railings. One last thing really quick. It looks like there is a door on the first floor, and to do that, the easiest way, most straightforward way, is to go to the door tab underneath the architecture tab, the door button, I guess, and that'll bring up a set of single doors that are going to be flush. It's just a type of door, and you have to hover over a basic wall, and I use the term basic wall very specifically because you cannot use this with a curtain wall, and I'll show you how to do that in a second. So this will only insert the doors in a basic wall. All you gotta do, select the wall that you want. You can start to distinguish the side that you want the door swing to be on, and you can also flip it by pressing the space bar and click, and then it will embed that door inside that wall, and then you can manipulate it there. You can also manipulate the door swing once it is actually set. Now, that's how to insert a door into a basic wall family. To do it in a curtain wall, you actually have to go in and select the specific pane of glass, the specific curtain panel that you want to change into a door. So to do that, you want to hover over the pane of glass or pane of the curtain wall panel that you want to change and tab in until you get a blue boundary around that panel. Click. It'll bring up a system panel under properties and whatever the panel is. So in this specific case, it's a glazed panel. And this is what is called a pin. So in a curtain wall specifically, any element like the mullion type and the curtain panel type that you've specified in the family, so we specified glazed system panel in the storefront family, it's going to come in as pinned. And to be able to manipulate that and change that to the door that we want, we have to unpin it. So you can either click that and we'll unpin it, or you can go up to the modify tool and click the unpin, which is just a pin with an X. So we've unpinned it. Now we can manipulate it and change it to a door. So click down, then go to the storefront double. I think there's no. Sorry, there's just the one. Curtain wall storefront double. Click that if you can. And now it has changed that entire pane of glass into a double door. And the reason why it's a little bit different from the one that you can embed into the basic wall is because when you embed a door into a basic wall, it comes in with a very specific predetermined dimension, right? So that door that we inserted into the wall, let me just do it again. That's a 36-inch by 84-inch door. That is not going to change unless you change the actual parameters in the family type. But it comes in specifically at 3 feet by 7 feet. Okay? A door within a curtain wall adjusts itself to whatever dimension you have determined it to be. So whatever the dimension of the panel was, that's what size the door is going to be. And if you manipulate the size of that door, so let's say I tab in and select the grid, which is that dashed line there. If I wanted to make it, instead of 10 feet, 7 feet, the door shrinks with it, right? So that's the difference between a curtain wall door and a basic wall door, and why you can't the two aren't indistinguishable from each other. So that's the lesson for today. I know this was very basic. I'll go over your assignment, which is just to modify this a little bit. And as always, let me know if you have any questions. And if you have any questions with the assignment, feel free to email me. All right, thanks.